Okay, welcome back. Now I'm going to be talking about total internal reflection and its use in the important technology known as fiber optic technology, right? In optics, we learned that when you have a medium, right, such as a tube, or it could be a water, swimming pool water, or anything, right? If you have a light beam coming from the tube, this is index of refraction, let's say the fiber optic cable, let's say. The index of refraction is the index of refraction of the fiber optic cable. Let's say it's 1.5 or 1.6, right? And then this is air, index of refraction of 1. So the light beam will come, right? And its natural tendency is to want to escape out, to refract into the air, right? So if it comes at a steep angle, it's going to reflect into the air at a tilted angle, right? It's going to speed up as it goes into air, then it's going to refract away from the normal line, right? This angle is going to be larger than the incoming angle. If you make it a little steeper, then it's going to refract like this, right? And then if you make it even steeper, there's a particular angle known as the critical angle. This is theta critical, where if the angle of the ray is pretty steep, then it won't even refract. It's going to glide along the surface. It's going to glide along the surface of the cable, right? It's just going to go in this direction, right? Like that. If I make it any larger than that, any larger angle than the critical angle, so this is theta is greater than theta critical, then it's just going to reflect back in. That's why it's known as total internal reflection. Then the beam is forced to stay within the cable and it can't escape out. This is why we use fiber optic technology to transmit our information, HD, TV, and many other cable stations, satellites. Why? Because since the beam stays in the cable, there's very little attenuation of strength, of the signal strength. And most of the signal strength stays in the cable and it doesn't lose its power and energy, right? Over transmission over many, many miles, right? So the fiber optic technology uses this concept of total internal reflection. So for the demo today, I have a plastic material here that is winding around like this, right? And I have a laser beam and I'm going to shoot it in the plastic cable. I'm going to turn off the lights. Okay, you can see here that I am shooting the laser beam, right? And you can see how it's reflecting back in. And then you can see most of the energy should be coming out from the end here, right? So you can see here how it's reflecting inside of the material, keeps reflecting back and back and back, stays in the material, and then basically comes out the end, right? Now if I shoot it steeper angle, right, this won't work. If I shoot it too steep, a lot of the energy might escape, right? But if I shoot it more straight, more steeper angle, then I will keep it inside of the fiberglass tube, right? And it will come out the end, and most of the energy will be retained. And so this shows you the fiber optic technology, the simple principle of keeping the beam inside of the material so that you have very little attenuation of signal strength. Okay? Thank you very much.